Hey there, all you cool cats and kittens. It's Carol here at Big Cat Rescue. No, wait, sorry. This is Mr. Rose here with Freshman Physics, and today we're going to talk a little bit about this activity that you have. This is activity number 2 with series and parallel circuits. So hopefully you've seen this worksheet. It's a Google Doc. I clearly spelled labeled wrong. I'm going to fix that right now. There we go. And on the Google Doc, the first thing it tells you, go to the website, etc., and so on. I have this set up already. But there is this picture of a series circuit. And then what we need to do is, notice A, B, C, D, E, so E, F, G, etc. You need to set it up with this many junction points. So then what we're going to do, the purpose of this, is to compare the interaction between a series circuit and a parallel circuit. We've done a lot of math with that. Now we're like doing the actual activity stuff with this. So I prepared this little circuit for you, and then I gave you a spot for you to type in all of your data. There's not much to calculate here at this portion of the lab. So what we do is we go to the Phet circuit simulation. Let me move my, I don't know what this is going to look like now. We go to the Phet circuit simulation, and I want to make sure that we have a couple things checked off correctly. So this is, once you follow the directions, the lab setup, and this is exactly how it's going to be presented. Now, if you notice, this picture looks very different. So what we need to do is, this is the lifelike. We need to click on the elements, and now that is close to what I want. But now in this top right corner, we have electron current and conventional current. Now remember, this is just a convention, exactly what Ben Franklin did. He messed everything up. We know, us people know, electrons, the negative things, are the things that move. But when we talk about electricity, we don't talk about electrons moving. We talk about conventional current. So I want you to click on that, and you get these little red arrows that now have a pointing direction, a positive and a negative. Now, obviously, I can't put A, B, C, D, E, F, G on this. But now we see these electrons, this current flowing in the form of the arrows. Now let me look at our activity. Notice I have 12, 5, 3, and 4 ohms. So we want to make sure that we do that correctly. So I click on my battery, and I want to make my battery 12 volts. I click on each one of the resistors, and I need to change the resistance so it matches. So I click on a resistor, 5, 3, and 4. I'm going to click on each section. This one has to go down to 5. Whoops. This one has to go down to 3 ohms. And this one has to go down to 4 ohms. And now I can take all of the measurements I need. Now I want to show you something. If for whatever reason I don't want to use a resistor, but I want to use a light bulb, I can do that, and the light bulb will function exactly the same way. I bring that back down to 4 ohms because a light bulb is just a special resistor that lights up. And now the only reason you'd want to do that is I can actually see something happening. So if I made all of my resistors light bulbs, I could see a difference happening, right? So this is a 5 ohm resistor. If I made it a 5 ohm light bulb, I could try and compare this light bulb to that light bulb, and maybe this one looks a little brighter or dimmer than this one based on those lines, right? When I change the resistance, those lines are supposed to represent the brightnesses of the bulbs. So you can use light bulbs instead of resistors if you want. It doesn't actually matter for this activity. All that matters is the values. So I'm going to go back to this diagram. And what we needed to do is we needed to use voltmeters and ammeters to fill out our chart. So electric potential difference is the voltage. So we needed to in order to find the potential difference between two different points, potential difference at A to B, B to C, C to D, D to E, is I take my voltage, I look at my diagram, A is there, B is there, so I put A where A is, and B where B is, and I get 0 volts. Now that means something that we're going to have to discuss in person or via Zoom. And when I move this around, I'm not going to give you answers. I'm going to change that. When I move this around, so if I go to, say, for example, B to C, well, that's B and that's C. If I put that there, and then put that there, I get 10.49 volts. So that's a potential difference that is going across this light bulb or that resistor. Now, that's not going to match any of your numbers because I changed things, but that's what we're doing. Now, I want you to notice this negative. All the negative means is that I put them in the wrong direction. We don't care about that. Like I said in the beginning, the negative, we are defining the direction of electricity. This just means I hooked it up backwards. So in other words, I can switch these guys, and now I'll get positive 10.5. So we're just reporting the magnitude. Now, to find the current, because I asked you about the current as well, the electrical current, all we need to do, it's easier to use this non-contact ammeter, this is a fake thing, is we take a little bullseye and we put it over what I'm measuring. If you want to use a real ammeter, you need to remove part of the circuit, remove a wire, and then insert the ammeter like that. And now reconnect it. And that'll tell you the current. So you don't need to do that. You can just use this non-contact one. Like so. And then answer the questions that I put out. Then on part 2, it's building a parallel circuit. So I've done that for you as well. Here's the parallel circuit. And again, make sure it's conventional current. We want to click on that to make sure it looks the same. And just like I did before, put the values correct. It was a 12-volt light bulb. I'm sorry, a 12-volt battery, so I make that 12 volts. I can change the resistance of each one of these to match the resistance 3, 4, and 5. So I'd match the resistance of that 3 ohms, 4 ohms, and 5 ohms. And you should see significant differences between the branches. So that's one of the observations I want you to look at. What's actually happening, you can see just in this video, like, whoa, look at those lines, they're going super fast. Not so fast. I know, I'm super excited. And you're going to do the same measurements, voltage and current, the exact same way. If I'm going to measure the voltage from A to B, I would take my voltmeter and put one side there on the app. From, say, B to G, I would go there to there, etc. Then I'm going to fill in the data table and answer any questions I have, and then we will discuss the pros and cons of all these circuits. Then moving forward into next week, we're finally nipping this in the bud, and we're going to go on to some cooler stuff, at least what I hope will be cooler stuff. We really do want to understand the difference between series and parallel circuits. They do have a direct application into our lives at home, at school, your cell phones, how those work, etc. So I want to have like maybe an overview conversation of electricity as well. Anyway, I hope this will help you work with the parallel and series circuits. Again, if you want to use resistors or light bulbs, they will function exactly the same way, but the light bulb, we can see what's happening in the app. That's it. I don't know how Carol ends her all you cool cats and kittens. So, fun physics puns. Stay lit. That works. This is Mr. Rose signing out for electricity. Stay lit. I don't think that works.